If you're new to Roblox Studio and want your game to look cooler, this video is for you. Today we'll learn about particle emitters and we'll also learn how to make a custom trail using particle emitters step by step. Okay, alright, so first of all, what are particle emitters? Particle emitter is an object that emits customizable 2D images useful for creating special effects, for example smoke for fire, etc. Okay, now we have this fireplace over here and we want to add particles to it to simulate fire and smoke. So first of all, you can add particle emitters to mesh objects, parts and attachments. I will add a particle emitter over here. Now as you see, the particles are being emitted but they are not what we expect it to be, right? So you can customize its various properties. So first property is color. Since fire is kinda red, over here you can slide the arrow and you can choose the color. Now what I'm gonna do is, if you click on it and if you click on 3 dots over here, you can actually change its color over a period of time. So in the beginning I want it to be reddish, but eventually I would like it to change its color to around, yellowish orange, just like in real fire. There we go. If you zoom out, you'll be able to see that the colors are changing over a period of time. But right now the trail is too long, right? So you can change that too. While changing that, if you scroll down, you can reduce its lifetime, which is essentially the duration for which the particle exists. So if you reduce the lifespan, it should ideally become shorter. There you go. You can make it even more smaller. In lifetime, you have both minimum values and maximum values. So what Roblox does is it will check for minimum and maximum and will assign a lifetime between these two values. It can be 4, 4.6, 3, and this is in seconds. So it indicates how long the particle is going to exist in the world. I'm going to reduce the lifespan. If you want it to have a single value, you can set min is equal to max. So it will have a single value. I'm going to reduce it further. Want it to be, yeah, there you go, much better. Now you can duplicate this too and it will become thicker. So for now I'm going to delete it. We are going to focus on it now. Right, so light emission. Light emission determines the glow or the intensity of the light emitted by the particle. Right now it's not emitting any significant amount of light. You can scroll it up all the way to 1 and it will start glowing, and you can scroll it back down. Yep, I'll keep it at around 0.3. Light influence refers to the influence of the environment, the surrounding light. For example, what comes in the environment? It's the sun. Where's the sun? Yeah, right there. The sun's light will also be affecting the particle, and to minimize the influence of the environment light, you can set it to 0, or if you want the environment's light to influence your particles, you can set it to 1. Size is what size does. Like if you increase the size, that particles become bigger essentially. So if I make it 4, yep, the particles become bigger. Kinda like, it's better, it looks like fire right now. Squash essentially just squashes it. You'll understand if I put it as 1 instead of 0. Yep, it becomes narrower as such. Yep. Property is texture. What texture does is essentially it's the image which is being rendered over here. If I remove the squash, you'll understand better. If you reduce the size for now, yep, the image being rendered over here is the sparkle image, which is by default provided by Roblox. You can change the texture of the particle. Texture as in the image being rendered over here. It can be anything. It can be any image. It can be like a noob image. It can be Roblox's icon. It can be Robux also. You've seen those effects where Robux floats out of certain objects, but that's also done by particle emitters only. Transparency. Now moving on to the next property, transparency. What transparency does is, it's quite obvious. It makes it transparent. If I set it to 1, it will be completely transparent, essentially invisible. You can set it to any intermediate value around 0.5. Yeah, there you go. It's like kind of transparent now. Set it to 0 again. Yeah, it's opaque, completely opaque right now. Now scrolling down, don't worry about Z offset for now, not that important. Emission direction. Emission direction means in what direction the particles would be emitted. For right now it's going in the top direction. You can change it to bottom. It will go downwards. It's going down right now, so if we go underneath this base plate you'll be able to see it. Yep, there you go. See, it's going downwards. Now you can change the emission direction again to front. It will go in the front direction. You can change it to left. It will go in the left direction. You can change it to top again. It will go in the top direction. Quite obvious. If you come up, moving up. Rate. Okay, lifetime. Again, lifetime. That is just discussed. So lifetime essentially is the seconds for which this particle is existing in the world. You can give it a range of values, minimum and maximum. For example, if I make the maximum 2, some particles would survive all the way for 2 seconds, so they'll go much higher. Yep, there you go. Some particles are surviving to 2 seconds. Most particles die around 1 second. So yeah, now moving down. Rate is the number of particles emitted per second. You can decrease it all the way to 7. See, lesser particles are emitted per second, or you can increase it all the way to 100. Much more particles are emitted per second. It's recommended that you keep it around, you minimize this because it takes up a lot of memory. So for mobile players it will be quite difficult to render, so I'm going to keep it around 16. Yep. After that, speed is also quite obvious. Speed is the speed at which essentially the particles are moving. So right now both minimum and maximum speed is 5. You can increase the maximum speed. Some particles will start to move much faster. You'll notice that they're also going higher. That's because distance is equal to speed into time. So some particles which are going fast also and whose lifetime is also large, they end up covering much more distance. So essentially, if you want to control the distance, what you're supposed to do is you're supposed to control both the speed and the lifetime of the particle. I'm going to reduce the max speed to 5 again. Spread angle. Spread angle is essentially the spread of the particles in a particular axis, both x-axis and y-axis. Right now it is just linear, it's going up in one particular direction, there's no spread. Now let's give some spread to x. I think you can go all the way to 45 degrees. So if I give 30 degree spread, as you can see, it's spreading around along x-axis. You can imagine that right now it was going linear, now it goes in either direction 30 degrees maximum. It can leave it up to 30 degrees in either direction. So it's essentially it has spread across the x-axis. I can increase it all the way to 45. What would happen is it will cover the entire thing. Yep. You can see 45 degrees in this direction, 45 degrees in this direction. Now if I set this to 0 again, we'll come back to the linear path in which it was traveling before. Now if you move over here like this, now we want it to deviate along about the y-axis, over here. To deviate it around y-axis, I'm going to set it to 45. So it will start spreading about the y-axis. And if you notice carefully, this is the y-axis of the object and it's spreading about the y-axis. So I think it depends on the local orientation of the object. So whenever you want to spread it on x-axis or y-axis, I would recommend that you try both, and you can appropriately rotate the entire object later on. For example, the particle emitter also rotates with the objects chosen. For example, if I rotate the entire model, the particle emitter would also rotate with it. Yeah. I rotated it. It appears linear in this direction. That's because the spread has gone in this direction. Yep. So the spread is respect to the local y-axis of the particle emitter, which depends on the y-axis of the object. It doesn't depend on the global y-axis. It depends on the local coordinate system. So if you rotate it, the particle emitter and the direction in which it emits also rotates. For example, if I rotate it like this, as you see, the particle emitter also rotates with it. It's like it's fixed to it. If I want, now I want it to come back to its original position, I can do Control Z. Control Z. Yep, there you go. Right. So next property in a particle emitter is, now we are going to discuss about how to dynamically change the size with time. So first of all, let me reduce the spread angle to 0. So it will be linear once again. Now we are going to experiment with the size. Now if you click on size, just like in color, you can vary the size over the lifetime of the particle. Right now it is having the same size. I wanted to increase its size somewhere in the between, and again decrease its size later on to a much lower value. Diminish it essentially. I close this right now. Yeah, you can see if you increase the lifetime, it will essentially travel a larger distance. So let's try doing that so that you can understand it better. Yeah, there you go. As you can see, the particles initially start off smaller. They increase the size somewhere in the middle, again decrease to a smaller value, and increase just a tiny bit. So if you close this, over here particles start off smaller, somewhere in the middle they attain their maximum value and start diminishing again to a very small value right about here, and again just before they fizzle out, they get a final push up and they increase in the size like a tiny bit. So that's how you can control the size of stuff. Okay, yeah, there you go. Now we can, our fire is completed. We can just add a smoke object to it and could live with it.